systems are revolutionizing healthcare. Specifically, we will explore how Azure's powerful platform is used to enhance chest X-ray diagnostics, utilizing advanced AI techniques to improve the detection and diagnosis of abnormalities. Give me 1 second. Great. So I have created a roadmap that promises an extensive exploration of fundamental concepts in our field. Our initial destination in the realm of exploring fundamental concepts. Here I will introduce the core principles, but theory alone is just a compass. The true essence lies in its practical application, so we will focus on putting theory into practice. Our trip continues navigating towards the expansive landscape of Azure AI Studio and chatbot integration. Finally, we reach our last port of call, Azure AI Language Studio. As we navigate through these time frames, each stop on our agenda serves as a beacon, illuminating new perspectives and deeper understanding. So let's start. As AI advances, it is now capable of developing new diagnostic methods, particularly within the healthcare sector. However, the involvement of artificial intelligence in such critical areas raises concerns about these reliability. This is where the importance of human oversight and expertise becomes paramount. By combining the precision and efficiency of artificial intelligence with the insight and judgment of medical professionals, we can ensure that AI-driven systems deliver accurate and effective results, ultimately safeguarding patient care. The image presents a timeline within key concepts highlighted at different stages, visually representing the evolution of AI in healthcare. Starting from the left, AI develops new diagnostic methods, symbolized by an icon, a brain filled with binary code representing AI's role in creating new diagnostic techniques. Then concerns about AI reliability, depicted by a robotic figure showcasing the uncertainties about AI's dependability in critical areas such as healthcare. Human oversight and expertise combined with AI, illustrated by a brain half and human figure, symbolizing the crucial collaboration between AI and medical professionals to ensure reliable healthcare outcomes. Accurate and effective AI-driven systems, represented by interconnected nodes, emphasizing the precision of AI systems when guided by human expertise. Then patient care safeguarded, depicted by a shield enclosing a family icon, highlighting the ultimate goal of AI-driven healthcare systems to protect and enhance patient well-being. This timeline serves to visually reinforce the message that while AI continues to advance healthcare, human oversight remains essential to ensuring safe, accurate, and effective patient care. Let's move to the next slide. In this slide, we see a clear representation of the balance between AI's efficiency and the critical role of human expertise in healthcare. AI contributes significantly to data-driven accuracy and enhanced diagnostic speed, but it's essential to remember that its role is to assist rather than replace medical professionals. On the right side of the balance, we highlight the importance of patient safety, oversight, and critical decision-making, which still rely on the expertise of radiologists. This ensures that AI-driven systems in chest X-ray diagnostics do not compromise patient care, but instead work alongside healthcare professionals to enhance overall diagnostic accuracy. The image visually emphasizes that while AI increases efficiency, the judgment of radiologists remain indispensable to ensuring that patient safety and accurate results are always the top priority. Today I'm going to go and walk with you through how we can leverage Azure's AI capabilities to improve healthcare services. We will focus on three key components, as you can see: the AI search service, language service, and integration with chatbot, and how they work together to provide an efficient solution for medical data processing. At the heart of the solution is the AI search service. This powerful service allows us to create sophisticated search experiences over large datasets. For example, in a healthcare setting, the AI search service can help professionals quickly retrieve relevant medical records, images, or patient information based on AI-driven queries. The language service complements the AI search service by allowing us to analyze and understand human language using natural language processing, aka NLP. We can extract important information from text-based medical records, identify entities such as medications or diagnoses, and even detect the sentiment behind patient feedback. Lastly, we can integrate these AI services with a chatbot. This allows healthcare professionals or patients to interact with the system through conversational interfaces. The chatbot can answer questions, guide patients through procedures, or help doctors find relevant medical information. So with this architecture, we are able to create a system that handles vast amounts of data while simplifying complex tasks for healthcare providers. By combining search capabilities, language understanding, and conversational AI, this solution leads to faster, more accurate decision making in clinical settings. Let's apply theory into practice. What is Azure AI Studio? Azure AI Studio provides a powerful and user-friendly platform that allows developers to seamlessly create, test, and deploy AI models using Azure services like Azure Open AI and Azure AI Speech. By leveraging the AI Studio chat playground, I configured my own chatbot to deliver accurate medical information about various conditions, symptoms, and risk factors related to chest X-rays. It can even guide users through potential next steps and treatments when abnormalities are detected. The initiative interfaces of Azure AI Studio enables easy customization, allowing me to fine-tune the assistant's responses and behaviors, making the development process efficient while enhancing the overall user experience. Though some features are still in preview, the platform remains highly effective for deploying innovative AI solutions in healthcare. Using Azure AI Studio, I created a chatbot, as I have said, that acts as a knowledgeable and supportive assistant, specifically designed to assist in detecting chest abnormalities via advanced AI-driven chest X-ray diagnostics. The chatbot provides clear, medically accurate information about various conditions, their symptoms, and risk factors. Additionally, it guides me on potential next steps and treatments when abnormalities are detected. So let's move to scenario one. The model is designed to help me, Philippos, by identifying and detecting chest abnormalities using advanced AI-driven diagnostics based on chest X-rays. I have made sure that the model's responses are not only clear and concise, but also medically accurate. It will provide detailed information about various conditions, including the characteristics, potential symptoms, and associated risk factors. Additionally, the model is instructed to describe any abnormalities it detects and to guide me on the next steps, whether that be recommending over-the-counter treatment, suggesting the need for prescribing medication, or advising a medical consultation where necessary. The goal here is to ensure that the AI can assist with making informed decisions while providing a supportive and medically accurate experience. Give me a second. So now we are into the Azure portal. I have already created a resource group named Chest. A resource group in Azure acts as a container that holds related resources for an Azure solution. These resources could include virtual machines, databases, storage accounts, AI services, and more. The purpose of this resource group is that can be managed collectively. All the resources can be managed collectively. Um, By organizing these services into a resource group, we can manage access, policies, and billing as a single entity. This method is especially useful when working on projects involving multiple Azure services like this one, such as AI language and AI search services. It simplifies monitoring and managing services that are related to specific solutions. So for the AI search service, I have already created the test X resource. So we can go to the Azure AI Studio chat playground. The AI search service in Azure is a powerful tool that allows us to build sophisticated search experiences over the content. In this example, as I have said, I have created a service named ChestX under the resource group Chest. The purpose of this service is to enhance search capabilities, making it easier to retrieve relevant data using AI techniques. So, as you can see here, I'm utilizing the Azure Open AI playground to deploy a customized GPT-4 model that I have named it skin cancer detection. The deployment is named like this, but in this development setup, I have provided the model with the specific instructions and context so that it acts as a virtual assistant for healthcare diagnostic. Originally, the model was configured to assist with the skin cancer detection, but now I have adjusted its purpose to identify chest abnormalities using chest X-rays. I give clear instructions in the system message area to ensure that the AI assistant responds in a knowledgeable and supportive manner. The assistant now delivers medically accurate information about detecting conditions related to the chest, but I can also adjust the parameters here in order to have more accurate result. So now I will show you a demo. I will click on Apply Changes. Here, as you can see, I interact with the model to ask about its purpose. As you can see, the model responds according to the instructions, explaining its role, assisting with the detection of various health conditions. Additionally, Azure Open AI Playground provides a JSON view of the data transcript for API integration. This ensures that structured data is captured. It can be used to store patient interactions or integrated with existing healthcare systems. Also, I can provide the test X-ray image for the demo, and we instruct the AI model to analyze it. So give me a second. So as you can see, the model identifies key features in the X-ray, such as the lungs, heart, diaphragm, and bones. It's able to note areas of increased opacity in the lungs, particularly on the lower left side, which might suggest fluid buildup or possible infection. From this analysis, the AI assistant point out potential conditions like pneumonia, pleural effusion. This demonstrates how the AI model can assist healthcare professionals by providing a detailed preliminary analysis, which can then be further confirmed through additional tests and by considering the patient's medical history. Also, as you can see in the playground, I can also integrate external data sources securely through the Azure platform. This allows me to gain insights from a boarded dataset, which the AI uses to refine its diagnostic suggestions. For instance, if I integrate in more chest X-ray data, the model can learn to recognize more complex patterns, of course, and improve its accuracy over time. So let's show you an example. Let's give to it 1 minute. Let's continue with the presentation, then we will come back. So let's continue. So by incorporating additional chest X-ray data and reference materials such as diseases of the chest, breast, book, the AI model can gradually learn to identify more complex patterns and enhance its accuracy over time. Through keyword-based searches, this process allows for continuous refinement of the model capabilities. I will show you the demo in a while. Let's go to the Azure AI Language Studio. Imagine you are a healthcare provider or a clinician. Have you ever wished for an easier way to organize and pull useful insights from medical data like prescription or patient reports without having to do it all manually? Medical records can be packed with information and details, making this process challenging. That's where Azure AI language comes in with a tool called Text Analytics for Health. This service helps break down complex medical text by identifying important keywords and connections. It has four main features. It highlights key terms like diagnosis, symptoms, and treatments. It links medical terms to standardized UMLS codes. It finds relationships between related terms like the type of treatment and when it happened, and it even labels terms with extra context, like certainty or condition, to provide more detailed insights. Let's imagine we are an insurance company needing to analyze a prescription for a claim. The document is in TXT file, and we log into Azure AI Language Studio to analyze it in real time. Azure offers services like summarization and translation, along with the pre-built and custom analytics models. For this example, I will use the pre-built text analytics for health. So We are back to the Azure AI Studio. Let's try it again. We gain an error. Don't worry. Let's move on to the scenario 2. So Azure AI's language service includes a powerful text analytics for health tool. Great. I have already created the language resource test pharmacy, so we can go on. So the text analytics for health tool allows healthcare professionals and data scientists to extract key medical information from unstructured text, such as doctor note, patient reports, or prescriptions. The process begins by inputting the text data into the Azure platform. For example, we can analyze a prescription where a patient is instructed to take various medications in specific doses. Once the text is uploaded, the tool uses named entity recognition for healthcare to identify and extract medical entities. So, in this example, the system detects medications such as ibuprofen, potassium, and coumadin, along with their associated doses, like 100 mg for ibuprofen. Let's click on run. So, as you can see, the model can distinguish between medication names, dosages, and other relevant medical information, organizing them in a way that healthcare providers or systems can easily interpret. After running the analysis, we can select the text view that shows us the original input alongside extracted entities, including medications and their dosages. Also, we can have JSON view that provides a detailed structured representation of the results with metadata such as confidence scores, offsets, which shows where in the text the entity appears, and relationships between the entities. Let's understand the relationships between them. When we enable the relationship display option, here we can see how different entities are connected. For instance, the tool links the dosages of 100 milligram with the medication ibuprofen through explicit relationships. This relationship linking is crucial for accurate understanding and further processing in medical systems. Azure service also integrate with external medical coding systems such as the UMLs. For each identified medication, the tool provides a UML code. For example, ibuprofen is associated with this code. This coding system is widely used in healthcare informatics, helping standardize terminology for billing, medical records, and insurance claims. Additionally, the ATC classification system can be employed by categorized drugs based on their therapeutic use. In our example, ibuprofen receives the ATC code M0, indicating its non-steroidal anti-inflammatory drug, NSAID, aka NSAID. As we said in the JSON output, each identifier is linked to additional metadata, including confidence scores that reflect the model's certainty in the classification of each entity. Offsets provide extra allocations of entities with the original text, ensuring precision. Relationships that show how different entities such as dosages and medication are connected. So by leveraging this service, organization can enhance their healthcare workflows, ensuring accurate data extraction and streamlined process for claims, billing, and patient care documentation. Let's try once again the Azure AI Studio. let's hope we have a result. So now we have a result. Give it a second. So now this allows me to gain insights from a broader data set that we have said earlier, which the AI uses to refine its diagnostic suggestions. For instance, if I integrate more chest X-ray data, the AI model can learn to recognize more complex patterns and improve its accuracy over time. This setup addresses one of the major challenges in radiology, reducing perceptual errors, especially in hard-to-see areas of chest X-rays. By utilizing AI, we can assist radiologists in spotting early-stage abnormalities, even in high-risk zones like the lungs, apices, or near the hilum. That my question is about. So this technology has the potential to significantly improve diagnostic accuracy and reduce the risk of misdiagnosis. Let's continue with the presentation. So now let's move to the next scenario. In this example, I will utilize Azure AI's text analytics for health to extract medical data from a complex patient report. The patient record begins with administrative details, including the record number, medical history, identifier, admission, and discharge dates, and a diagnosis of pneumonia confirmed by chest X-ray. The AI tool analyzes this unstructured text using named entity recognition for healthcare, identifying critical entities such as diagnosis, pneumonia in this case, procedures, chest X-ray, and symptoms like pain. The system also extracts details about the patient's history of present illness, such as the coronary artery disease and the results of a stress echocardiogram. As you can see in the patient report, this 54-year-old male was initially admitted with pneumonia, confirmed by a chest X-ray. However, his medical history is quite complex due to a significant history of coronary artery disease. Over the past few months, he had experienced progressive angina, and in July, he underwent a cardiac catheterization, which revealed to totally occlusion of the RCA and 50% occlusion of the left main artery. These findings indicate the high-risk cardiac condition, which adds to the severity of his pneumonia diagnosis. Additionally, I must consider his family history, which is also significant for heart disease. One of his brothers passed away at the age of 52 from a myocardial infarction, and another brother underwent coronary artery bypass grafting. This familial predisposition to heart disease is a critical factor in his pain plan, as it suggests a strong genetic link to cardiac issues. We can see in this patient record the diagnosis of pneumonia. The document indicates multiple instances of pneumonia which are linked to the UMLS code. This diagnosis was confirmed through a chest X-ray examination. Additionally, we have noticed that the patient age is extracted as an entity, which is critical detail in understanding the context of the diagnosis. Next, the admission and discharge date are clearly marked. Moving forward, we observe the examination findings. The results of the chest X-ray further validate the pneumonia diagnosis, reinforcing the accuracy of the condition's assessment. It is also important to highlight the patient medical history, specifically the significant history of coronary artery disease and progressive angina. These pre-existing conditions are crucial qualifiers that contribute to the broader understanding of the patient health profile and the management of pneumonia. Lastly, pneumonia is also recognized as a symptom or sign of the patient's present illness, and this too is linked to standardized medical terminology, providing a clear and structured representation of the clinical scenario. Let's see a demo. Give me a second. So now, let's upload the record information here. Okay, so nice. As you can see in this patient report, the Azure AI tool automatically identifies important clinical entities. It picks up on medical conditions like pneumonia, as I have said, and coronary artery disease, as well as treatments such as cardiac catheterization and bypass grafting. Additionally, it extracts family history, noting instances of myocardial infarction and coronary bypass surgery. This level of detail helps organize the report into move structure sections, making it much easier for healthcare professionals to interpret. So, uh, now what's really interesting is how the model goes beyond just identifying terms. It actually maps out relationships between different entities. For example, it connects the entity 52-year-old brother with myocardial infarction, highlighting the familial history, which is crucial in clinical decision making. Furthermore, the system even recognizes assertions like whether the patient condition is worsening or stable. This kind of insight can be invaluable for a doctor analyzing the case of this patient. Let's move on with the presentation. So, thank you all for joining me today. Your participation means a lot. I look forward to seeing you again soon. Keep exploring. Thanks for being here.